The technical name for a Delta Lake service is Open Delta Service. It is a three-phase electrical system that uses only two of the three phases. The third phase is left open or disconnected. In an Open Delta service, the two active phases are connected to form a delta configuration. The voltage across each active phase is the same as the phase-to-phase voltage of the original three-phase system. However, the voltage from each active phase to the dead phase is zero. Some advantages are reduced cost. Open Delta services require less equipment and materials compared to three-phase services with all phases active. Another advantage is simplicity. Open Delta systems are relatively easy to install and maintain. A disadvantage is lower efficiency. Open Delta services are less efficient than three-phase services with all phases active, as they only use two phases instead of three. Open Delta services were originally used primarily for air conditioning, but they have also been used for other applications such as small industrial machinery, lighting systems, and traction systems for electric vehicles. Open Delta services have been phased out in many areas due to their lower efficiency. However, they are still in use in some regions and for specific applications where cost and simplicity are more important than efficiency. An Open Delta transformer bank, also known as a V-phase transformer bank, is a type of three-phase transformer connection that uses only two single-phase transformers instead of the usual three. This configuration is often used when the load is small relative to the available three-phase power, or when one transformer in a three-phase bank has failed and needs to be replaced. The Open Delta configuration can provide three-phase power, but with a reduced capacity compared to a full three-transformer delta-delta or Y-delta bank. Understanding the operation, limitations, and calculations involved in an Open Delta transformer bank is crucial for electrical engineers and technicians working with power distribution systems. The primary purpose of an Open Delta transformer bank is to provide three-phase power using only two transformers. This can be useful in several situations, including firstly, temporary or emergency situations when one of the three transformers in a standard delta-delta bank fails. Secondly, situations where the three-phase load is small and doesn't justify the cost of installing a full three-transformer bank. Thirdly, rural areas or remote locations where the cost of transporting and installing three transformers is prohibitive. Open Delta configurations offer several advantages, but also some disadvantages that must be considered when deciding whether to use this type of connection. Advantages include firstly, lower initial cost since only two transformers are required. Secondly, lighter weight and smaller size compared to a three-transformer bank, making it easier to transport and install. Thirdly, continued operation even if one transformer fails, although at reduced capacity. Disadvantages include firstly, reduced capacity compared to a full three-transformer bank. The Open Delta bank can only supply about 57.7% of the capacity of a delta-delta bank using three identical transformers. Secondly, unbalanced voltages under unbalanced load conditions. The voltage regulation is generally poorer than with a three-transformer bank. Thirdly, increased losses due to circulating currents within the transformers. The transformers in an Open Delta bank are more heavily loaded than in a delta-delta bank, leading to higher losses. The basic principle behind the operation of an Open Delta transformer bank is that two single-phase transformers are connected in such a way that they provide three-phase voltages. The two transformers are connected in a V configuration, with the primary windings connected to two phases of the three-phase source and the secondary windings connected to the three-phase load. The voltage across each transformer is the line-to-line voltage of the three-phase system. However, the current in each transformer is higher than in a delta-delta bank since each transformer must carry the current for two phases. The capacity of an Open Delta transformer bank is less than that of a full three-transformer bank. The capacity of an Open Delta bank is only about 57.7% of the capacity of a delta-delta bank using three identical transformers. This is because each transformer in the Open Delta bank must carry the current for two phases, which increases the loading on the transformers. The following formulas can be used to calculate the capacity of an Open Delta transformer bank. Firstly, K volt amps open delta is equal to square root of 3 times volts line to line times amps line. Secondly, K volt amps open delta is equal to 0.577 times K volt amps delta delta. When calculating the size of transformers needed for an open delta bank, it's essential to consider the load requirements and the reduced capacity of the open delta configuration. Each transformer in the bank must be able to handle at least 57.7% of the total three-phase load. It's also important to consider any future load growth when selecting the transformer sizes. If the load is expected to increase significantly in the future, it may be more economical to install a full 3-transformer bank initially rather than upgrading from an open delta bank later. To properly install and maintain an open delta transformer bank, there are several key considerations. Firstly, ensure proper connections. The transformers must be connected correctly in the V configuration with proper polarity. Incorrect connections can lead to circulating currents and overheating. Secondly, provide adequate protection. Each transformer should be protected by fuses or circuit breakers to prevent damage from overloads or short circuits. Thirdly, monitor voltage balance. Regularly check the voltages on all 3 phases to ensure that they are balanced. Unbalanced voltages can indicate a problem with the transformers or the load. Fourthly, inspect for overheating. Periodically inspect the transformers for signs of overheating, such as discolored paint or insulation. Overheating can indicate overloading or a fault within the transformer. Fifthly, perform regular maintenance. Follow the manufacturer's recommendations for regular maintenance, such as cleaning and tightening connections. Open delta transformer banks are commonly used in several applications. Firstly, rural power distribution. Open delta banks are often used in rural areas to supply 3-phase power to farms and small businesses. Secondly, temporary power. Open delta banks can be used to provide temporary power during construction or maintenance activities. Thirdly, backup power. Open delta banks can be used as a backup power source in case of failure of the main power supply. Fourthly, small industrial loads. Open delta banks are suitable for supplying small 3-phase loads in industrial plants. When troubleshooting an open delta transformer bank, several common problems may arise. Firstly, unbalanced voltages. Unbalanced voltages can be caused by unbalanced loads, faulty transformers, or incorrect connections. Check the load on each phase and ensure that the transformers are properly connected. Secondly, overheating. Overheating can be caused by overloading, poor ventilation, or internal faults within the transformer. Check the load on each transformer and ensure that the cooling fins are clean and unobstructed. Thirdly, blown fuses or tripped circuit breakers. Blown fuses or tripped circuit breakers can indicate an overload or short circuit. Check the load in the circuit and inspect the wiring for any signs of damage. Fourthly, low voltage. Low voltage can be caused by overloading, a faulty transformer, or a problem with the incoming power supply. Check the voltage at the transformer terminals and at the load. The selection of transformers for open delta banks must adhere to industry standards to guarantee safety and performance. Key standards include firstly, Institute of Electrical and Electronics Engineers, or IEE Standard C57.12.0. This standard covers the general requirements for liquid immersed distribution, power, and regulating transformers. Secondly, National Electrical Manufacturers Association, or NEMA standards. NEMA standards provide guidelines for transformer construction, testing, and performance. Thirdly, Underwriters Laboratories, or UL listing. UL listing ensures that the transformers have been tested and meet safety requirements. The efficiency of an open delta transformer bank is typically lower than that of a delta-delta bank due to increased losses in the transformers. The efficiency of a transformer is defined as the ratio of output power to input power. The losses in the transformer are primarily due to firstly, core losses. Core losses are caused by hysteresis and eddy currents in the transformer core. These losses are constant and do not depend on the load. Secondly, copper losses. Copper losses are caused by the resistance of the transformer windings. These losses increase with the square of the current. In an open delta bank, the transformers are more heavily loaded than in a delta-delta bank, which increases the copper losses and reduces the overall efficiency. The impact of unbalanced loads on the performance of an open delta transformer bank can be significant. Unbalanced loads can cause, firstly, voltage imbalances. Unbalanced loads can cause the voltages on the three phases to become unequal, which can damage sensitive equipment. Secondly, increased losses. Unbalanced loads can increase the losses in the transformers, reducing the overall efficiency of the bank. Thirdly, overheating. Unbalanced loads can cause the transformers to overheat, which can shorten their lifespan. To mitigate the impact of unbalanced loads, it's important to firstly balance the load as much as possible. Distribute the load evenly across the three phases. Secondly, use properly sized transformers. Ensure that the transformers are sized to handle the maximum load on each phase. Thirdly, consider using a delta-delta or wide delta bank. If the load is highly unbalanced, it may be more appropriate to use a full 3-transformer bank. The use of open delta transformer banks can lead to several power quality issues, including firstly voltage sags. Voltage sags are temporary reductions in voltage that can occur when large loads are switched on or off. Secondly, voltage swells. Voltage swells are temporary increases in voltage that can occur when loads are suddenly disconnected. Thirdly, harmonic distortion. Harmonic distortion is the presence of harmonic frequencies in the voltage and current waveforms. These harmonics can be caused by nonlinear loads such as electronic devices. Fourthly, voltage imbalance. Voltage imbalance is the condition where the voltages on the three phases are not equal. To mitigate these power quality issues, it's important to firstly use power quality monitoring equipment. Monitor the voltage and current waveforms to identify any power quality problems. Secondly, install power quality improvement devices. Install devices such as surge suppressors, harmonic filters, and voltage regulators to improve power quality. Thirdly, properly size the transformers. Ensure that the transformers are sized to handle the load and minimize voltage sags and swells. Understanding the costs associated with open delta transformer banks is essential for making informed decisions about their use. The costs can be broken down into firstly, initial costs. Initial costs include the cost of the transformers, installation costs, and any necessary switchgear or protection equipment. Secondly, operating costs. Operating costs include the cost of electricity losses in the transformers, maintenance costs, and any repair costs. Thirdly, life cycle costs. Life cycle costs include all costs associated with the transformer bank over its entire lifespan, including initial costs, operating costs, and disposal costs. The advantages of open delta transformer banks compared to other transformer configurations include firstly, lower initial cost. Open delta banks require only 2 transformers, which reduces the initial cost compared to a full 3-transformer bank. Secondly, smaller size and weight. Open delta banks are smaller and lighter than 3-transformer banks, which makes them easier to transport and install. Thirdly, continued operation in case of failure. Open delta banks can continue to operate even if one transformer fails, although at reduced capacity. The disadvantages of open delta transformer banks compared to other transformer configurations include firstly, reduced capacity. Open delta banks have a lower capacity than 3-transformer banks. Secondly, unbalanced voltages. Open delta banks can produce unbalanced voltages under unbalanced load conditions. Thirdly, increased losses. Open delta banks have higher losses than 3-transformer banks. To improve the performance of an open delta transformer bank, consider firstly, balancing the load. Distribute the load evenly across the 3 phases to minimize voltage imbalance and losses. Secondly, using properly sized transformers. Ensure that the transformers are sized to handle the maximum load on each phase. Thirdly, installing power quality improvement devices. Install devices such as surge suppressors, harmonic filters, and voltage regulators to improve power quality. Fourthly, performing regular maintenance. Follow the manufacturer's recommendations for regular maintenance to ensure that the transformers operate efficiently and reliably. When designing an open delta transformer bank, several factors must be considered to ensure optimal performance and reliability. Firstly, load requirements. Determine the total three-phase load and the load on each phase. Secondly, voltage requirement. Determine the required voltage on each phase. Thirdly, transformer size. Select transformers that are sized to handle the maximum load on each phase. Fourthly, voltage regulation. Consider the voltage regulation of the transformers and ensure that it meets the requirements of the load. Fifthly, protection. Provide adequate protection for the transformers, such as fuses or circuit breakers. Sixthly, cooling. Ensure that the transformers have adequate cooling to prevent overheating. The maintenance and testing requirements for open delta transformer banks are similar to those for other types of transformers. Key maintenance activities include firstly, visual inspection. Periodically inspect the transformers for signs of damage, such as leaks, corrosion, or overheating. Secondly, oil testing. Periodically test the transformer oil for moisture, acidity, and other contaminants. Thirdly, insulation resistance testing. Measure the insulation resistance of the transformer windings to ensure that the insulation is in good condition. Fourthly, turns ratio testing. Verify the turns ratio of the transformers to ensure that they are operating correctly. Fifthly, load tap changer maintenance. If the transformers have load tap changers, perform regular maintenance to ensure that they are operating smoothly. Safety considerations are paramount when working with open delta transformer banks. Always follow proper safety procedures, including firstly, de-energizing the equipment. Before working on any electrical equipment, de-energize it and verify that it is de-energized using a voltage tester. Secondly, wearing personal protective equipment or PPE. Wear appropriate PPE, such as gloves, safety glasses, and arc-rated clothing. Thirdly, using insulated tools. Use insulated tools to prevent electric shock. Fourthly, following lockout-tagout procedures. Follow lockout-tagout procedures to prevent accidental energization of the equipment. Fifthly, working with a qualified electrician. Only qualified electricians should work on open delta transformer banks. Open delta transformer banks have been around for many years, but they are still used in some applications today. The future of open delta transformer banks is uncertain, as they are being replaced by more efficient and reliable transformer configurations. However, it may continue to be used in niche applications where cost and simplicity are more important than efficiency. The impact of technology advancements on open delta transformer banks is significant. New technologies such as solid-state transformers and smart grid technologies are making open delta transformer banks less attractive. Solid-state transformers are more efficient and reliable than traditional transformers, and smart grid technologies are enabling more efficient and reliable power distribution. The integration of renewable energy sources with open delta transformer banks can be challenging. Renewable energy sources such as solar and wind power are often intermittent, which can cause voltage fluctuations and other power quality problems. To mitigate these problems, it's important to firstly, use power quality monitoring equipment. Monitor the voltage and current waveforms to identify any power quality problems. Secondly, install power quality improvement devices. Install devices such as surge suppressors, harmonic filters, and voltage regulators to improve power quality. Thirdly, properly size the transformers. Ensure that the transformers are sized to handle the load and minimize voltage sags and swells. Open delta transformer banks can be used for emergency power backup in certain situations. In the event of a power outage, an open delta bank can be used to provide power to critical loads. However, it's important to ensure that the open delta bank is properly sized and protected, and that it is connected to a reliable backup power source. Comparing open delta to closed delta configurations reveals key differences. A closed delta, or delta-delta configuration uses 3 transformers connected in a closed loop. This configuration is more efficient and can handle unbalanced loads better than an open delta configuration. However, a closed delta configuration is more expensive and requires more space than an open delta configuration. Open delta transformer banks represent a variation on the open delta concept. An open delta bank uses two transformers, with one transformer connected in a Y configuration on the primary side and the other transformer connected in a delta configuration on the secondary side. This configuration can provide better voltage regulation than a standard open delta configuration. Understanding the specific applications where open delta transformer banks are most suitable is crucial. Open delta banks are most suitable for applications where firstly the load is small. Open delta banks are less efficient than three transformer banks, so they are best suited for applications where the load is small. Secondly, cost is a major concern. Open delta banks are less expensive than three transformer banks. Thirdly, space is limited. Open delta banks are smaller than three transformer banks. Open delta transformer banks play a role in three-phase power distribution systems. They provide a cost-effective way to supply three-phase power to small loads. However, they are less efficient and have poorer voltage regulation than three transformer banks. Future trends in transformer technology will likely impact the use of open delta configurations. As transformer technology advances, more efficient and reliable transformer configurations are becoming available. These new configurations may eventually replace open delta transformer banks in many applications. The importance of regular maintenance and inspection for open delta transformer banks cannot be overstated. Regular maintenance and inspection can help to identify potential problems before they lead to failures. This can save time and money in the long run. Key maintenance activities include firstly, visual inspection. Periodically inspect the transformers for signs of damage such as leaks, corrosion, or overheating. Secondly, oil testing. Periodically test the transformer oil for moisture, acidity, and other contaminants. Thirdly, insulation resistance testing. Measure the insulation resistance of the transformer windings to ensure that the insulation is in good condition. Fourthly, turns ratio testing. Verify the turns ratio of the transformers to ensure that they are operating correctly. Fifthly, load tap changer maintenance. If the transformers have load tap changers, perform regular maintenance to ensure that they are operating smoothly. The impact of environmental factors on open delta transformer bank performance should be considered. Environmental factors such as temperature, humidity, and altitude can affect the performance of open delta transformer banks. High temperatures can cause the transformers to overheat, while high humidity can cause corrosion. High altitude can reduce the cooling capacity of the transformers. In conclusion, open delta transformer banks are a cost-effective way to supply three-phase power to small loads. However, they are less efficient and have poorer voltage regulation than three transformer banks. As transformer technology advances, open delta transformer banks may be replaced by more efficient and reliable transformer configurations.